Welcome to today's video, everyone. There's a lot in store for you today. In today's video, I'm going to be covering YOLO version 3, how to install and run it in the cloud, taking advantage of free GPU that anyone can use. And I'm also going to be showing you how to train your very own custom object detector in the cloud using that same free GPU. So really anybody can follow this tutorial and will be able by the end of it to have their very own custom object detector that will be able to detect all sorts of objects, whatever you choose, whatever you can imagine, you'll be able to do it. Let's do it. Alrighty, so first things first, you're going to notice that we are running our notebook on Google Colab. So we're going to be using Google Collaboratory for this tutorial. So you will need an email which is connected to Google Drive, so we have access to Google Drive, and that's where we can create Colab notebooks. So if you don't have one of those, go ahead and create one. It takes like 2 to 5 minutes because Google Colab offers everybody free GPU acceleration on their cloud VM so that they can run programs for up to 12 hours at a time using GPU, and it's totally free. So that's what we're going to be using for this video. So it's exciting, and I'll show you guys how to get this notebook up and running for yourself. So you're going to go ahead to the descriptions, comment the link to this notebook itself, and then you can actually just go ahead and I'll show you. There's two ways. This is the first. You go ahead and paste it into a new browser, or your browser you're using. New browser for me, so that it doesn't automatically log me in. And it should look like this. You're going to go to Open in Playground, and then there should be an option here just to copy to drive. And if you click that, it will open up this Google Notebook for yourself that you can edit and actually run commands, because I have it in view only mode so that none of you guys can change it for each other. So yeah, that's one way. Easily just click copy to drive and it'll pop up in your own Google Colab. Otherwise, you can just search in Google Colab, hit Google Colab, and it will actually open up a welcome notebook for you. And you can go File, New Python 3 Notebook, or Upload Notebook, and go to my GitHub, which will also be in the description below, YOLOv3 Cloud Tutorial, and you can just go and download as a zip, and then unzip it, and upload this tutorial notebook to Colab, just like that. File, Upload Notebook, and it'll come up as well. So yeah, there's two ways to do it. I recommend just doing the copy to drive way, much easier, and it'll open it up with all the images and stuff for you because the images are a little wonky down here. So now I will exit that. So now back to the notebook. How do we actually get GPU enabled right off the bat? So I have pictures here for you, but I'm just going to show you. You just go to Edit, and then you go to Notebook Settings, and this will be set to none. You're just going to go from none to GPU, click GPU, and hit Save. And now you are, this little cloud VM that spins up for you in the notebook is now GPU accelerated, and you guys can run programs using GPU. So if you've had headaches in the past with your computer not being fast enough or not having a GPU, that problem is solved. Wahaha. So now that GPU is enabled in our notebook, we can go ahead with the tutorial. So we're going to be cloning and building Darknet from Alexei AB's famous repository, and we'll be building it using Make. But that all comes pre-installed on here. It's like a Linux VM, so we can run the Make commands. Don't have to worry about downloading anything else. So first things first, you can run each cell by clicking on the play button one at a time and going down. You can also just go up here, really click, and click one button, run all, and that will do all this base work for you, cloning Darknet into our VM. So if we go to the file system, we didn't have Darknet here before, and now Darknet is here. So it's cloned it into our VM. We can see we have all the files. So that's perfect. This next cell, what it does is it is actually inline editing this make file within the Darknet folder, and it is turning OpenCV equals 0 to 1, GPU to 1, and cuDNN to 1. That is enabling us to build Darknet with OpenCV and GPU enabled. So in the past, you might not have been able to put those variables, but you can. Everything comes pre-installed on your VM, like OpenCV and CUDNNN. The next cell is just verifying that yes, CUDA is on your cloud VM. And if you didn't know, each notebook spins up a cloud VM associated with it that you're connected to. So that when I talk about cloud VM, it's just the notebook itself. But yeah, so you can see that we have version 10 from NVIDIA. That's perfect. And then this big command, which takes us a couple of minutes to run, or a minute or so, is actually building Darknet by running the make command. It's building Darknet and all the dependencies from the binary files, and it will allow it to be run because of those flags we changed to run with GPU enabled. So yeah, if you might not have been able to do that in the before, or if you're on Windows, it still works because we're in a cloud VM. So yeah, it's super easy. Just one line, make, and it will build it for us. So we're going to scroll down. It's built. And now we're getting the pre-trained YOLO version 3 weights from the official site. This will allow us to do detections on 80 classes right out of the bat. It comes out of the box with trained model on 80 classes. So we're going to take advantage of that to show you just that we've installed and built Darknet properly before we jump into training our own custom detector. So it's grabbing the weights files and saving them to the Darknet repo. Oh, we jumped ahead a bit there. Oh, you can see it's working. But yeah, so we go back up here. We've got the weights. It saved it here. We can see it, YOLOv3.weights. Perfect. We've gotten it. And then the next cell is a couple helper functions for us to show images, upload files, and download files to our cloud VM, to our notebook. So now we're actually running the detections. If you want to see the classes that out of the box YOLO weights can detect, what classes they can detect, objects, click on this and it'll show you little buttons and show you all the different classes. So now comes the time to run our Darknet Detect. This is the command, Darknet Detect. To your config file, the one that comes pre-trained, we have it, the weights, and the image. And then imshow predictions.jpg allows us to pop up the image because the cloud VM doesn't dynamically do it right after you detect like it might on your local machine. It doesn't have that capability. So this helper function will just show us the predictions on the image. So we can see that it ran the first example on data/person. This comes with the repository. So you will have this already. So this will work for you. It's loading in all the weights and all the layers. And then you see this warning that it cannot open the image. That's what I was talking about. So we run the imshow with predictions.jpg. Every time you run Darknet, it will save the image with the detections overlaid on it to predictions.jpg. So if you're ever looking for that, it's just in the Darknet folder, and it is predictions.jpg. Where is it? Right there. Perfect. So it's there, and we see that we ran the detection on person.jpg. It has detected a person, a dog, and a horse within the image. And if we scroll back up at the bottom of the output, it will show you the detections and the confidence level. So the dog's 99%, the person's 100%, and the horse is 100%. And you can see that it predicted this image in 21 milliseconds. 21 milliseconds. That's super fast, super, super fast. A split less than a second, like so much less than a second. And if that was not GPU enabled, that would be about like 7 or 8 seconds per detection. But we were able to run it with our GPU, our free GPU, in 21 milliseconds, which is absurdly fast. That's real time, super, super fast. So that's the power of GPU enabled Darknet. And then we're getting, this is just a second detection, and it's going to predict it right away at the bottom. It's loading it in. This time we're doing the dog image, and this is another classic image. We can see a detected bicycle, 99% confidence, dog 100%, and truck 94%. And then it's showing the image because we ran the imshow function, and you can see the detections perfectly. So run all will go all the way down to this 10th cell. This cell right here is cert equals false. Just runs it so that when you run all, it will cause an error here so that it no longer continues to run because the next cells and all the way down are dependent on certain files that you may not have yet. So that's why it runs here. But if you just at the beginning go run all, it will go all the way to this point, hopefully. Well, it will. I'm 100% certain because it works on all the VMs perfectly with accuracy. And you should see all of this up to this point just by doing one click, runtime, run all. So that's pretty sweet. So if everything's working for you up to this point, I would go ahead and probably click this link right here, pop it open. Oh, wow, what's that? Jeez. Ooh. I would definitely hit this button right here. Too bad I already have. But yeah, I would definitely hit subscribe and like this video, please. If you're enjoying this so far, it would mean a lot, and you'll be up to date with all the latest YOLOv3 content and all the new comings. So hit that subscribe button, smash a like on this video. I'd really appreciate it. Thanks, guys. So back to the actual tutorial. We now can upload local or Google Drive files to use. So if you want to run detections on more than just a couple images there are within the repo itself, you can do this. So you can find one of a cool class of one of the 80 classes. Like there's the toothbrush, kites, skateboards, like there's a bunch of them. There's 80 that you want to detect for, and you can go ahead and actually choose files to upload. I show a couple examples here. Yep, running this upload command just lets you pick an image from your local computer. So I can go ahead and do this. Let me go to downloads, and I will take this photo. I will link I will have all these photos that I use within the tutorial in my GitHub repo, so don't worry, they're in there. You just go to my repo, and they're in the images folder. So street, save streets, and now I'm actually going to run the detection on street. So you hit this, and it's going to go ahead and run the detection on that photo that I just uploaded to the notebook. You can see street.jpg right there. So you can see this one. It's a busy intersection of a street, and you can kind of get a grasp of the crazy classes that YOLO can predict straight out of the box. Like it's getting a cell phone out of somebody's hand that's pretty far away. Like that's pretty sweet. It's getting the cars on the road, the bus behind us, the traffic lights themselves, handbags, and of course a bunch of the people, all the people walking across the street. So out of the box, the pre-trained weights are crazy good, and you can use them for a lot of different applications. You can also mount files in from your Google Drive, and I'm going to recommend this as a way that you move your files around so that everything gets saved. So if you go to my drive, I have an images folder with 2 images. I'm going to be using the plain one right now. So you're going to go ahead and run this command, and it will mount your Google Drive in. You're going to click this link. You're going to copy the confirmation code that you get from once you click on the link, and you're going to go ahead and paste it back in here, and that's going to go ahead and connect and mount your Google Drive. So everything you have in your Google Drive will now be accessible within the notebook. So we're perfect. We can see that it worked. And now if I just list what's in my drive, I should be able to see what's there. So you can see it has Colab notebooks, images, and YOLO. I go back to my drive, and I have Colab notebooks, images, and YOLOv3. And YOLOv3 is where I'm going to hold a lot of my configuration files that we'll get to later for training my custom object detector. So now I have that. I'm going to now point it to that plain image that I showed you, and we're going to see if that works. So it's now going to look at this plain.jpg image and hopefully run the detections on it. So it's loading in the model, and airplane 100%. That's pretty cool. Perfect. It got the airplane detected. So we've uploaded files, and now let's download files. So how can we get these files back to our local machine and save them? Because when the runtime ends and you close the cloud VM, anything saved within here will disappear, and you won't be able to access it again. So any files or images that you want saved to your local machine or Google Drive, you will have to download them. So just hitting this will download to your local machine using our helper function. It just will go ahead and download predictions.jpg. Perfect. I'm not going to open it. I trust it. And then this command copy will take predictions.jpg and save it to my Google Drive under the images folder and call it detection 1. So this is a quick way to just start firing images into your Google Drive when you run detections. So I'm going to go ahead and run that. And we're going to see that it's going to copy over the image, and it should pop up now in my Google Drive if I reload this. Give it a second, another reload. And there it is. It's called Detection 1, what I renamed it. And we have the detection of the airplane. So it's pretty cool. You can see how you can easily move files to your Google Drive, download them, upload them, and everything. And now comes the moment of truth. We're going to start training our custom YOLO version 3 object detector in the cloud on the GPU for free. I know, it's crazy. Who can believe it? And you guys are killing it so far if you've gotten to this point. It's about to get a little trickier, but we're going to get through it. So in order to run your YOLO version 3 detector, you need a custom dataset, a custom config file, object.data and object.names files, and a train.txt with a test.txt as optional. I'm not going to show that here, but you can do it. So there's two ways to gather custom datasets. I have two previous videos. One where I show you guys how to use Google's Open Images dataset, which has millions of images that come with detections on them, so that you can then just download them and their classes. And I've shown that in a previous video. You can link to the video right here and explore the dataset Open Images by looking at this link. And then there's a toolkit which helps you download all the images and convert their annotations to YOLO form. And I've done that in my GitHub repo here. So I really recommend this way. This is the better approach. Super fast, and Open Images has 600 classes that you can choose from and create a custom detector for. So go ahead, and I show you guys the commands that I've used, what the file should look like in order to do it. So you can just follow these steps and easily from this repository create custom dataset. So go crazy, look in the Open Images dataset and find weird classes that you can create your detector for. For mine, I'm just doing kind of a safari animals. So I've got elephant, giraffe, hippo, tiger, and zebra images. And I'm going to be creating my custom detector to detect those animals. So that's the first way. The second way, I also have a video on. This is the link if you want to go watch it. You can mass download images from Google Images and then use an annotation tool to go and actually manually label all the images. As you can see, that's a longer process and a little bit more tiresome. So I don't recommend that unless you have no other way of getting the images you want for your custom detector, and that's the only way to go. It is a viable option. It just takes some time to create the manual labels, but yeah, you have to do it. So now that you've got your data set, everything's under control, you're going to have to move your data set into your cloud VM so that you can access it and train on it. So this is recommended because it greatly reduces the time to fetch files and locate files if they're already in your VM. So quick commands. So once you've got your data set, you should have a folder that looks like this, JPEGs and text files, one for each. So if I go into my folder of the toolkit, you can see I use the toolkit. Originally, my file name with all my photos was called this. You're going to want to go ahead and rename it to obj and delete if there's a label folder here after you have all the labels. Delete that. We don't need it. But yeah, so we can see it looks proper. I've gone ahead and renamed it obj for the custom detections training it. And then you're going to want to go ahead and right click and go send to and do a compress folder, a zip folder. So you're going to want to zip it so that it isn't, we're not like downloading thousands of images, because this data set I created has 1,500 images. We don't want to transfer that. It would take forever. So you're going to zip it, and then you're going to go to your Google Drive. And I recommend creating a YOLOv3 folder for everything. And you can see that you just drag and drop it into here. It's downloaded, so now I have obj.zip in my Google Drive, and now I can access it inside of our notebook. So that's awesome. So now I can just list my drive and make sure it's there, that I can see it. I can see obj.zip. What this will do is it's going to copy the zip file into our cloud VM at our root directory. And then the next command is going to go and unzip it into the proper data folder where we need all of the data for our custom detector that we want to train on. So perfect. And now I'm going to go ahead and unzip it. And you can see it's now inflating all the images and text files inside our Cloud VM at a much faster pace than if you just transferred over all the files without zipping it. So yes, zip it. It will save you tons of time. Do it. And call your files the same names as mine, so you can just run these same commands. So now we need to configure our other files, our configuring files for our custom detector. So you probably have seen this in my previous video, how to train a custom object detector. That was on your local machine. The steps for these configuration files are the exact same. So I recommend going to check out that video, starting it at like the 5-minute mark. I think that link does, and it'll show you how to prep all these files. But if you want to see them, how I did it, again, I have them in my repository, my custom config, and my object.datas and .names. So you can look at it. But yeah, you can also, so what this does is this command here, this next cell, it will copy, I'm just going to change the name here so I don't accidentally overwrite what I already have in my Google Drive. So it's going to copy the normal one that works on the pre-trained model config file from the config folder in your Darknet, in the Darknet, and it's going to copy it to your Google Drive, and that way you can edit it. If you run this command, it will just download it to your local machine, and you can edit it. So you're going to have to edit this config file in a text editor or code editor. I'll show you actually how to do it here. So I will download it to my Google Drive. Perfect. So it's going to be hopefully in here if I reload in a second. Yep, this is the one. I changed the name to 2 because I didn't want to. This is the one I'll use for my training. I've already edited it. But what you're going to do is double click on your file, open with, and go to text editor. This is super easy, and you can edit in Google Drive. So I recommend doing this. And what you're going to go ahead and do is start off by commenting these 2 lines and uncommenting these 2 lines. So this will set it up for training, batches 64 and subdivisions 16. That should work. And then you're going to go ahead and change your max batches to 2,000 times however many classes you're training for. I'm training for 5 safari animals, so I'm going to change this to 10,000. And then you change your steps. So you change your steps to 80% of your max batches. So this is 8,000 for me, 80% of 10,000, and then this one is not 90% of your max batches. So that'll be 90 for me. And then the other changes you make are you just Control F and look for YOLO. And in each of these YOLO layers, the square brackets is the layer, you're going to change it to your number of classes. So I have 5 classes, the 5 safari animals, and you're also going to change the filters in the convolutional layer above it. And this you're going to change to, it's going to be the number of classes you're training for plus 5 times 3. I'll pop that up on screen to show you guys. So for me, that's 5 plus 5 times 3 is 30. And you're just going to go and do this for each of your YOLO layers and each of the convolutional layers before them. So 5 and 30, 5 and 30. And then one more, there's 3 of each, 5 and 30. And then you're just going to go ahead and save it to your drive. One thing to note, if you run into errors later down the line, I recommend that you try with random equals 1. What that does is as you're training, it will change the file size, the image files in size, scale them up and down so that your detector is used to seeing different sized images and whatnot. But if you run into any errors for some reason on your VM that says like out of memory, or if you want a faster detections, faster training time, I mean, then I set all those to 0, but leave them as 1 to start. Okay, so save. And now we can go back. So all of these are explained in here. You can go and I explain the random equals 1 if you want a faster training. But now what I'm going to do is copy my custom config back to here. So I'm just going to go ahead and copy it back in. And now so now I should have, if I go into my Darknet config and scroll down to the bottom, I have that custom config that I just edited, and it's now back here but in the proper version that I need to run my detections, to run my training, I mean. So now comes the time to create your own custom object.names and object.data files. So I explained these in my previous video as well, but I'm just going to quickly show you guys again. So you, in a text editor or code editor, either on your local machine or just straight from Google Drive, going to new and going to more, you can create text files. So you're going to want to have your object.names, and this is going to be each of your classes, one per line, that matches exactly the classes.txt file, I guess it's too far up there, that you did for the toolkit. If you use the toolkit, it has to match exactly the same. So that's all your classes. And then you're also going to create your object.data folder, which is kind of just like legend of where everything is for the training model, so that when it trains, it knows where all your file folders are. So what you're going to do is just make it look like this. First line's classes and the number of classes. That's all you're going to change. Keep these the same, even though text.txt, we're not going to be using it. That points to where we just saved object.names, or where we're going to save object.names. And then for backup. So backup is the folder that throughout the training process, it will save weights to, that will allow you to run the detections and see how it's doing. So the weights folders are, what loads in and allows your custom detector to do its custom detections. So it's the most important part. And what we're doing here is we're actually saving it into our Google Drive. So we're saving it to our Google Drive in our YOLOv3 into this backup folder. So you're just going to come in here and go new folder, create a backup folder, and this will work for you. One thing I just noticed that I forgot to mention, that way up here that we're doing is when we first create the link between our Google Drive right here, we're creating a symbolic link. So the original path when you mount your Google Drive in is this: content, G drive, my drive, and it has a space in it, my drive. And I found that a lot of commands, that was causing me errors, having a space in my folder structure. So what we're doing is we're creating a symbolic link so that every time we're trying to call that, we can just equal it to my drive, and it's much easier. It doesn't have a space, so it doesn't really screw up anything. So that's what this file is. It's just creating that link, mapping this file extension to that file extension, and it works. So forgot to mention that. Just wanted to mention that. So that's perfect. So yeah, we're creating that, and we're pointing the backup to save our weights files to our Google Drive, and I'll explain why later. So let's download my object.names and object.data that I've created and that are in my Google Drive. So let's copy them in. Perfect. They're going to go. And finally, we're going to create and generate our train.txt file. This is a file that just shows all of the paths relative to where you're training from to all of your images. I've also have that in my GitHub repo right here. So it's in here as well. So generate train, just download it, put it to your Google Drive, and then you can run this command to copy it in or upload it by uncommenting that line right there. So I'm going to copy it in, generate train, and then by running that command, it will generate the train.txt file for you with all of the over 1,000 images that I have. So if you were doing that manually, that would take forever. I've created a script that does it for you. So I'm just now going to run generate train, and it will generate that file automatically for us. And if I just now ls to make sure it's there, we can see train.txt, which wasn't there before. And if I went to open it, it would look like this. It has just one per line, and it points to each image, not the text files. And so open that by going and finding it in data, train.txt, double click, and it will open it up on the right side and make sure that yours looks the same as this. So the final step, right before we can now run our training, is to download a pre-trained convolutional layer weights. So what this does is it kind of scopes out the model architecture for you automatically. So we're going to go ahead and grab that. So it's not that your model isn't starting from like net zero scratch. It's building off of these weights that are already optimal for each of the layers. it's not like the weights to detect all the classes. It's just the layers themselves will learn these weights over time. So we're just throwing it in so that it doesn't have to learn those weights. It already has them. So it's kind of confusing, I know, but it just makes it so it's faster. You converge faster, and your model can start working properly and accurately a lot faster than if you just did it without this. So use it, use it, use it. Run this command, get the darknet53.conf.74 file in, and now we can train our custom detector. So now we are ready to do our custom detections, which is sweet. So we can now, I show some tips and tricks for running it. So one thing to note is that Google Colab has an idle time of between 30 to 90 minutes that if you're not on like doing anything inactive, it will kick you off its VMs because it doesn't want to waste GPU like having it stored waiting aside for you when you're not using it, which is kind of fair. But this these commands right here will allow you so that it generates an auto click every 10 minutes in your console so that it thinks you're still active even though you're not. So it's kind of a hack to not get you kicked off of Google Colab. Sorry, Google. Don't hurt me for this. But yeah, it works. Because this training will take several hours depending on how many iterations you chose for max batches in your config or how many classes you're trying to detect for. It can take a long time to run. So what you're going to want to do is copy this. Just go to copy selection and then hit Control-Shift-I, and that'll open up the console inspector. And what you're going to go ahead and do is just copy paste it in here and click enter. And that will stop it from automatically kicking you off and saying that you're idle so that you can run this and kind of walk away from your computer, go to dinner, go with friends, come back and have it running. I also recommend going to your settings and going to your power and sleep settings. Let me go to, I know it's from display. So you go to display settings and then go to power and sleep. So just in your settings. And I always check these when I'm running YOLO. When plugged in, don't turn off. And when plugged in, never go to sleep. So that way when I'm plugged in my computer and letting it run on here, it won't turn off and stop the cloud VM from running. So that's also maybe a good practice to do. But now comes the time where it's ready to run. You just follow this command if you've done everything properly. And you run this don't show flag because it'll keep trying to pop up a chart showing you how your training's doing. But that will actually cause it to break because I said on the cloud VM, you can't pop up images dynamically. So we're just going to go ahead and click train. And hopefully, fingers crossed, everything should work for you here. And you should start training your custom detector. It's that easy. Hopefully, you haven't had too much troubles up to this point. And you can see that it's resizing images. That's what that random flag does. So if it's trying to allocate additional workspace for you and it's failing here because maybe you don't have as much storage on the cloud VM that you're using than I do, just go back to that config file and set random equals 0 so this won't happen. But you can see it should be working. If you look here, this is the iteration we're on iteration 3, and this is your loss value. My loss is over 2,000 right now. But you want that'll get down to hopefully under 2. When that loss is under 2, that's when your model's fairly accurate and detections should start working properly. But you can see it's doing an iteration every 5 seconds or so, and that will change based on the image sizes that it's detecting for. So it will take a few hours to run this, but with that command, you can just go work for the day and stuff like that. And when this isn't running, you can actually just show this image chart.png. And what that does is chart.png will show you a nice curve of your loss versus iterations over time so that you can see how your model is doing. I can't run that right now because it's training. You can't run 2 cells at once, I don't think. And then here's a trick that while it's running, it will save this YOLO custom last weights to our My Drive in our Google Drive backup. I've run this before, so I have some other weights here. So it will save a new file here with your up-to-date weights every 100 iterations through, which is perfect because say something happens and your Google Colab goes idle or it kicks you off after 12 hours for some reason. you don't want to lose those weights, because if you had it in here, your backup, you would lose that. If it crashed, you would lose the weights and have to start from scratch again, and that is brutal. But because we're saving it in our Google Drive, it will continuously keep our weights in here, and so that if it crashes, we have the weights. We have the weights. Thank God. You don't know how annoying that is when you run this and the weights get lost after hours of training. And then we can actually load the weights back in and do the exact same detector train command from the last weights, and it will pick up training exactly where it cut off. So I can actually go and end this. Let's just see what iteration we're on. Oh, it's really far down. Okay, let me scroll down on this. You can see that it's working. It's powering through. So if I go to, I'll interrupt it and show you that this works. So if for some reason you got cut off, I'm gonna clear the output for this one. And I'm now going to run this command, the same command, but now pointing instead of to the Darknet pre-trained weights to the weights that I've started building off of. And we'll just run that command. And it's loading everything in properly. And we'll see that it'll pick up training, hopefully where it laid off. And this for me will be, because it only saved 100 iterations and I didn't get to 100 iterations, this should be for me somewhere way different. So yeah, I trained this earlier up to 1200 iterations to show you guys. You should let it keep going forever, and my loss is under 1. So you can see that it goes down pretty quickly. So after 1200 iterations, it's down to under 1. After about 300 iterations, hopefully you're down to under 5 for your loss value. But my 1200 is loaded in from where it stopped when I cut it off earlier at a previous time, not on this demo. So it's loaded that in perfectly, so I can now stop it again and showed that for some reason it cuts off, you come back, your computer crashed, go to your Google Drive, back up, and you have custom last weights. And it will also save a weights folder every 1,000 as a new file. So this one's called 1,000, next one would be 2,000, 3,000 as you go. So that works well. So we can now run our custom object detector. So let it run for a while, come back, let it train. This is perfect. Mine's been training for a while. I've trained it over 1,000 iterations. You would want to keep training it longer to keep that loss curve going down and down as far as you can. But for me, this works perfectly. And now I can run my custom config. So right now our config file is pointed to have 64 batch size and subdivision 16. To run your custom detector, you're going to want to set those back to 1. And we can do that in line with this quick command. So I'm just going to run it. And we can now run our detection using this detector test command. So you first parameter point it your object.data, your custom config, and then now you point it to your weights. So my drive, my custom last weights, and the image you want to point it up to. I'm pointing it at a Safari image, and then this threshold parameter shows that anything under 30% confident I'm not going to show. You can put that in if you want, you don't have to. And then it's going to show it. So let's run that, and it's using it off my custom last weights, which you just saw was 1,200 iterations, so it might not be perfect. But it's running our custom detector, and it will open it in a sec. Boom, there we go. So this image, it doesn't show everything perfectly because it doesn't have tiger and hippopotamus and stuff. But you can see that after 1,000 iterations, and after that was 1,200 to be exact, it's pretty decent already, knowing that that's a zebra and that's a giraffe. Obviously, it's not perfect. It didn't catch this zebra or this zebra, which would have been really hard. But my detector was gonna train on 10,000 iterations, and that was only 1,200. So like just over a tenth of the time that I was gonna let it train for if I was trying to optimize this. Just for the purpose of this tutorial, I cut it off early so I could get this video out to you guys. But yeah, so if you're running for something that you want perfect detections, keep running it all the way to that max batches. And then I can also show you that chart.png to show you a good representation. So you're just going to pop up in this chart.png. And so right now it's not showing anything because I hadn't let it save again after loading in my new detector, so it wiped it. But you would see that after your custom training and just leaving it in one run, that you'll have a blue graph drop all the way down here, because you can see that mine just started to plot again right here, because that's where I just picked up training. Because every time you stop training, it wipes the stuff from before and starts new, the chart. So my previous detector went down steep to here, and I just started to train from this point, and you would have seen it go down even more. So you can see that one blue dot, but when you do this, you should see a lot, like hundreds of dots going down, showing that your loss is going down over time. So that's pretty much it, guys. Now you've been able to hopefully be able to train your custom detector, and I did a Safari one, and hopefully you guys can do your own. Show me some cool stuff. I'd love to comment down below what you're detecting on, like what your classes are. I'd love to see the kind of cool custom detections that you guys are trying to detect. So comment down below what you're detecting on, and also if you could, please smash that subscribe and like button so that you're up to date with my newest videos, and it helps the channel grow. So I appreciate it. Thanks, guys. See you next time.